Hello again. So this is going to be the second video as it relates to Enzyme Kinetics lab for biochemistry, and remember this is an Excel tutorial video. So I've already made one video going over part 1 or week 1, basically page 2 of the handout. So this video will be covering the data analysis that you need to do for week 2. So that is pages 3 and 4 of the handout. Just a couple reminders on what you did. So you'll have 36 wells on the plate, rows A, B, and C. And remember that row A was substrate only, row B was substrate plus enzyme, and row C was substrate plus enzyme plus inhibitor. And then a couple other things to point out. Same thing as week 1. All of the volumes totaled to 250 microliters. So in row A you had substrate plus 20 microliters of water. Row B you had 230 microliters of substrate plus 10 water and 10 for enzyme. And in row C, instead of water, you had inhibitor, 10 microliters of inhibitor. Total volume is 250. And we're basically going to be doing something similar what we did for last week. So this is what your data is going to be. This is what your data is going to look like when you get it from the plate reader and save it to Excel. I've added this up here just for the sake of the video, and we'll be going over this. So these are the steps we're going to do, and some of these are similar to what we did for week 1. We have a couple of extra steps. Still using Beer's law. Still going to be using the same extinction coefficient and path length. So just to refresh your memory, the extinction coefficient, you do not have to figure it out. It is given to you on the last page of the handout. It says right here, extinction coefficient at 405 nanometers is 18,800. Units are inverse molarity, inverse centimeters. And then the path length, we talked about that already. The rule of thumb that we learned from the protein spectroscopy lab was 0.25 centimeters per 100 microliters. And as we just pointed out, the total volume in all the wells is 250 microliters. Do the math, path length will come out to 0.625. Make sure you understand this. You're going to have to probably put this in your lab report as a sample calculation. So this is what your data is going to look like. Again, these are our steps, and I've already laid out some of the framework just to save us some time. So first thing on this list, and just in general, these first few steps here, you could do these in any order, really. This is just the order that I'm going to do them in, that I'm going to show you. Again, this is just an Excel tutorial video. I'm showing you how I personally would do it. If somebody came to my office hours, this is how I'd end up showing them. But if you're more competent in Excel, you can do these in a different order if you like, or you can lay out your spreadsheet differently. Anyway, first thing, convert time from seconds to minutes. So we did that last week, but we'll do it again. I've already got my cell label over here. So remember, we can type in a formula. Of course, we can do this on our calculator, maybe even do it in our heads, but let's use Excel to do this. So equal sign to start a formula, and I'm going to go over here and click on this cell, divide by symbol, and then 60. Enter key. And of course this is 0. 0 seconds is 0 minutes. And then to copy and paste, there's a little small black square. You can click on that, and it'll copy and paste down below. Now, one thing that Excel often does, especially with repeating decimals like this, is it will give you an unnecessary amount of sig figs, or maybe too few sig figs. So just to show you, there are these two buttons up here. You can increase decimal or decrease decimal. So we'll just do something sensible, maybe 2 decimal places. And then this, we can copy and paste it down here as well. And I usually use my keyboard quite a lot, hitting the escape key to deselect this, but I'm going to try and use my mouse as much as possible so you can see what I'm doing. Alright, so yeah, what was our next step? Subtract off row A. So why do we need to subtract off row A? Well, remember, row A was substrate only. Row A is checking for the autohydrolysis of the substrate solution. That's that yellow, it turns the yellow color in the presence of enzyme, but it's entirely possible that your substrate had a little bit of yellow color to it before you even started working with it. So that's what we're going to try and take into account, is any yellow color that was already part of the solution before we even got a chance to start the enzymatic reaction. So what we'll do, again, we can just create a formula and then we're going to copy paste to make our lives easier. We just want to make sure that we take, so this is B1 at time 0, and subtract off the corresponding time and location from row A. So I'm clicking B1 times 0 minus A1 at time 0. And this is my formula, and I'll hit enter. And then I'm just going to go ahead and copy this down and then paste this across. And you notice that all of these are 0. They're negative actually, but keep in mind that on your plate, if you followed the instructions anyway, your substrate concentration in those first two rows was 0 anyway. You shouldn't really have any color. There should have been very little or no yellow color in these because it had 0 substrate. So if you see negative numbers, it's okay. Don't worry about it. So now we need to do the same thing for row C, and just in general what we're going to be doing is analyzing row B data and row C data in tandem at the same time, and then we'll put them together later on at the end of this video. You're going to have several graphs in your report, obviously, and your TA will most likely ask you to plot your row B data and your row C data side by side so you can decide if your inhibitor of choice is competitive or non-competitive. Anyway, so what we can do, we can copy this, paste it down here, but keep in mind when I paste the formula, it does change what it's pointing at. So if I double click on this, I can see now it's pointing at this one minus this one, C minus B, and that's not what we want to do. We want to do C minus A. And you can either type the formula in fresh, or another trick you can do is you can actually pick up these squares. It's outlining. You can see there's a green outline. You can pick this up and move it around. So what I can do is pick it up and just bring it up here. And then when I'm done, I hit enter. And you can see now it's doing C1 times 0 minus A1 at time 0. Hit enter. I hit enter after double clicking so I don't accidentally mess up my formula. So then we're going to just copy across, and there we go. And if we double click on this very last one, we can verify, yes, it's doing C12, the last one, minus A12, that very last one. Good. Alright, so what's next on our list? We just did subtract off row A, average your data. So if you remember from the first video, we had row B data and row C data, and we averaged it because it was the same thing. But in part 2 of this enzyme lab, row B is completely different from what's going on in row C. In row B, if you recall, as we said earlier, it has substrate plus enzyme. Row C has substrate plus enzyme and inhibitor. They're different reactions. So we're not averaging row B and row C. Instead, what we're averaging is B1 and B2, B3 and B4, B5 and B6. And furthermore, each individual time is each one's its own time, basically. So these two, and then average these two, and then average these two. And again, that's the protocol. If you did everything correctly as instructed, B1 and B2 should be the same, B3 and B4 should be the same, B5 and B6, etc. So that's what we're going to do. I've already got my stuff labeled over here to save some time. Now the trick for doing this that I always recommend my students, well actually first let me copy my time over here, these values. Now I'm not going to make the same mistake I made last time in the other video if you remember, but I am going to copy this. Now if I just paste this over here, of course it's going to also paste the formulas I'll just show you what I mean. If I just click paste, that's clearly not what I want. It doesn't go from 0 to 0.03, it goes from 0 to 2. Undo. Instead, what we can do is paste special. We can tell it to just paste the values, so it'll just paste the 0 to 2.0. And again, I'll fix my sig figs really quick, and then we can copy this, paste it down below, and then I'll hit the escape key to deselect that. Okay, now let's do the averaging part. So like I said, we're going to have to average these two, and then average these two, and then average these two. So remember how to type in an average. It's equal sign to start a formula, and then we can just start typing the word average, and you can see it's being populated with suggestions. And when average is highlighted, you can hit the tab key. It'll fill that out with the parentheses. And we can do number, comma, number, or we can just come over here and select the two values we want to average, and then hit enter key when we're done. So you see it's averaging those two. Enter. And now we can copy this downwards. Now if I just copy this over to the right, double click to inspect, you see it's averaging 2 and 3, and that's not what we wanted. We wanted 1 and 2 averaged, and then we wanted 3 and 4 averaged. So I'm just going to click undo. So instead of copying it 1 over here, what we can do, and actually I need to expand this a little bit so I have the room. We're going to copy this, but then we're going to paste it 2 columns over. And I'll just do that for all of them. So now you see, if I double click on this one, it's averaging B3 and B4. If I double click on this one, it's averaging B5 and B6. And that's exactly what we wanted. And then this whole mess here, we can copy this, paste it down here. And it's already done for row C, as you can see. So great, that's what we wanted to do. Now you have all these empty columns. Well, nice thing about Excel is you can actually just go ahead and delete these columns. So I'm just clicking on the column header, right click, delete, and that just clears up these empty columns, and it won't mess up your formulas or anything. So we can double click, like on this last one for example, and we can verify it's still averaging B11 and B12. So we're good there. Let's delete this one more to clean it up. Alright, so that's that. What was next on our list of things to do? So we just did average your data. Convert from absorbance to concentration. So we went over this in the previous video, but I'll go over it again more quickly. So we're going to use Beer's law. Again, extinction coefficient, 18,800. Got that from the handout. Path length, we talked about that, 0.65 centimeters. If you don't remember, maybe go rewatch the first video or go watch it just to make sure you understand what we're going to be doing. And then of course you need to understand the units for this. You're going to have to put this sample calculation in your report. Just in general, we're doing a lot of stuff in Excel, and you can't just blindly use Excel. You need to understand all of these operations we're doing so you can have sample calculations in your lab report. So first I'll just go ahead and copy the time over. Now, what we did before in the previous video, where we have to do absorbance divided by extinction coefficient and path length to get the concentration. So we can start our formula with an equal sign, go over here and click on the absorbance value, divide by symbol, open parentheses for order of operations, because what we're going to do is divide by both of these values. And we could type them in manually, but I want to use Excel to show you guys this $ trick that we introduced in the previous video. Asterisk for multiply, click on that one, close parentheses, and now we need to multiply by 1,000,000 because we need the units to be in micromoles. According to the lab handout and Dr. Lefler's online recitation video, the units for the concentration of the product needs to be in micromolar, However, the extinction coefficient is given to you in molar. So how many micromoles are in 1 mole? 1,000,000. So we're going to multiply by 1,000,000. Enter. Now, one thing that, like I said, we introduced in the previous video was the use of the $sign. So if I just copy paste this down below, I'm getting garbage. I'm getting garbage because it changes which cell it's pointing to. So when you copy paste a formula, it changes the formula as well. And you can see these have moved. Now this one's not pointing anything, and it says can't divide by 0. So the solution for that is the $sign. So first let me undo this. So what we do, since M7 and M8 were pointing to our extinction coefficient and path length, relatively speaking, we can insert a $sign. And again, this tells Excel not to do what it naturally does, not to change what it's pointing at. We're not going to put $signs here because this was our absorbance. We actually do want that to change as we copy and paste down and across. But we want it to keep on pointing at the same extinction coefficient and the same path length. So I'm going to hit enter now that I've edited my formula. And now I will go ahead and copy down and across. Maybe clean up my sig figs a little bit. I encourage you to clean up your sig figs occasionally just because I know students often want to copy and paste these tables that they're creating in Excel directly into the report, but you really don't want to have too many sig figs. I'm sure your TA might be pulling his or her hair out when they see tons of sig figs for no apparent reason. Anyway, we can now copy this whole thing and paste it down here for row C. Paste. And let's just double click on one of them, verify, okay, good, it's pointing at that. And of course it should still be pointing at our extinction coefficient and path length. Anyway, so that's that. Let's see, next step. We just did that one. Now we're going to subtract off times 0. So this is something that we also did in the previous video. Why are we doing this? Well, keep in mind that when you add enzyme to row B and row C, there's probably going to be a small amount of time in between adding the enzyme and the plate actually going into the plate reader, maybe 5 seconds or so. The enzyme reaction has already started, and so we're going to take that into account. So basically what we're going to be doing is that all of this data here is going to get the initial time value subtracted off from it. And we can do that in Excel pretty easily. First, let me copy our time, bring it over again. And so we're going to be doing this the same way we did it in the previous video. Equal sign, click on this guy, subtract, and click on it again, which may seem kind of strange, but we're setting up a formula for easy copy pasting. That's the whole point. Now, we're going to use the $signs again. Now, since this row, this times 0 is in row 27, I want to make sure that it's constantly pointing at row 27. However, I do actually want it to change the column that it points to as I copy and paste. But I want it to always stay pointing at row 27. So what we're going to do is come up here and add the $sign just in front of that 27, but not this part. Enter key. So now you can see as we copy down, double click on this one, it's taking that very last entry and subtracting off the times 0. That's what we wanted. Now if I copy this across, double click on this last one, it's changed the column, but it's still pointing at row 27. Now you can see I had my formula double clicked as if I wanted to edit it. I did something and now it's messed up my formula. You can always hit enter or just delete it and undo. Anyway, that's why I always hit enter. Double click, hit enter, because it's very easy to mess up your formulas with that. It's a very valuable tool for verifying that what you just did was as expected. Anyway, We could copy and paste this whole thing down here, but it's still going to be pointing at row 27, and B and C are separate experiments. So instead what we can do is perhaps copy just this one, and I'm going to show you one more trick maybe you didn't know about before. So double click, you see, like I just said, it's taking this one, but it's subtracting off row 27. We need this to be down here. What we can do, and I think I showed this, but you can pick this up and drag it, so I'm just going to do that. Drop it there. Dollar sign's already right there, so that one's good to go. Copy down, and copy across. Double click on this one to check, and it's doing exactly what we expected. Enter key. Alright, so we are just about ready to graph. Let's check our list. Subtract off times 0, graph and get the slope. So actually there's also calculate substrate concentration. So let's talk about this really quick. Now in the lab handout, they gave you instructions to create these solutions. So the stock concentration of substrate, if you recall, was 5 millimolar. And you were asked in lab to create several dilutions of that substrate, 2.5, 1.0, 0.5, 0.1, etc. And then you also have 0. And they asked you to lay them out on the plate in this fashion. However, if you notice this italicized part, keep in mind that these are not the actual concentrations that will be present in the assays. Each assay will contain 230 microliters of substrate in a final volume of 250. Therefore, the actual concentrations will be slightly less. You will need to calculate the exact concentrations. So that's what this is referring to. Calculate substrate concentrations. And I've already started this over here. It's a very simple M1 V1 calculation. So M1 for all of these is right from the handout, 0 through 2.5, right here. V1 is 230 for all of them. Again, from the handout, following the instructions, we added 230 microliters. V2 is 250 for all of them. Again, because all of them you took 230 and added 20 microliters of something else, either water plus enzyme or enzyme plus inhibitor. And then M2, I typed in a formula. So let me just show you guys how I did that. So equal sign to start the formula. I'll do open parentheses just to make sure the order of operations work as I want them to. Clicking on M1 times V1, close parentheses, divide by V2, hit enter, and of course this one comes up 0 because we had 0 for the M1 concentration. But then we can copy this guy over, and there are concentrations. So these will be the concentrations that we actually use in our graph. And then the units, well again, the units right here, it said millimolar, so that's what we're going to go by. These are all millimolar. And that's what I have written down here. I've already copied this in here, typed them in individually. And the reason why I do this is because in a moment when we make our graph, it'll just make creating our legend that much easier. Anyway, so that was this one. Now I'm going to backtrack and do graph, get slopes. And we did this in the other video, basically the exact same thing. Before it was concentration of product versus enzyme concentration. This time it's going to be concentration of product versus substrate concentration. And that's also known as the Michaelis-Menten plot. But first we have to do concentration of product versus time. So let's do that. Again, we just select our data, insert. Don't ever do line graph in this class, trust me. Scatter plot. I like to do a connect the dot scatter plot, but your TA may prefer one or the other. So I'll just do this one for now. And this happens quite a lot. This looks like crap. This is definitely not what we were expecting. And as you can see, Excel highlights the data it's pulling from. And right now, it thinks this top row are X values and all of these are Y values, when it should be these are the X values and all of these are the Y values. But it's a very simple fix. just click on your data. So click on one of the data points, select data, and then this switch row and column button. Click OK, and there's our graph. That looks much better. And we can do the same thing for row C. Select all of this, insert, scatter plot, and it looks like crap again, so let's just quickly fix that. Switch row and column, click OK. Just move this down here so it's out of the way. Alright, so we should probably label these. We're just going to get the slopes. You may or may not have to include this graph in your report, but it is good practice to label things so that when you come back to working on your lab report the night before it's due, you can remember what you were doing. So it's disappeared, but chart tools here, if you click on this, all of these extra buttons show up, and I like to use this button, this layout 1. It just immediately throws up a title and axes labels for me. So we can just quickly label our stuff. We'll do it down here as well. So let's see. Y-axis, what was on our y-axis? We had concentration of product. And then what were the units of concentration of product? Well, remember, we were using Beer's law. Beer's law would give us the concentration of molarity, but remember we had to multiply by 1,000,000 to put it into micromolar. So the units here should be in micromolar, and I'm just going to use some Greek letters for that, for the micro, capital M. And then down here, what is this one? X-axis, time in minutes. And you can see it goes up to 2 minutes. Alright, make sure I spelled everything correctly. I think I did. Okay, so then our title, Y versus X, so concentration of product versus time. And then we can go ahead and label these while we're at it. Now, one easy way to label is you can right-click on the data, go to Select Data, and then over here you can click on your different series, and what you can do actually is click the Edit button, click on this button here, and then you can click on the label that you've made for yourself already. Enter key, click OK, and you can see over here it's changed. This first one is changed to 0. Next we'll do series 2, edit, click, and I'll go over and click on the second label. And I'm just going to do the rest of these really quickly. Alright, last one. There we go, got those labeled. So now we can more easily tell the difference between them for the next part. So we have to get the slopes, and we did this in the first video. We're going to do it again. It's very important that you do get the slopes in order. We need to be able to, for the next graph, Michaelis-Menten, pair up the velocities with the substrate concentrations correctly. So this first one looks like it's down here. Actually, I'm just going to do them from reverse order, so I'll do the 2.3 first. That one's up here. Right-click, add a trend line, and we're interested in the slope, so we are going to display equation on chart. Of course, it's going to be a linear trend line if you have to choose that first. We don't need to do set intercept at 0 or display our squared value. You shouldn't really need that for this one. But we do need the equation, so we'll do that. Click close, and here's our formula. So one thing that I like to do, because it is so critical that you don't get these out of order regardless of what your data looks like, I like to just drag these off to the side so I can keep track of them. So let's see, next one was this red one. Oh, sorry, no, we're going from bottom up. This 0.092. And if you have any trouble, feel free to make your graph larger so you can really make sure you click on the correct one. 0.092. Okay, I'm going to click over here just to make sure I grab the right one. You can always resize your graph later for the sake of putting it in your report. Next one is this purple one. And I'm sorry, this part may be a little bit tedious, but if I knew of a faster, more efficient way to do it, I would certainly be telling you about it. Alright, last one is the 0, of course. Slope is probably 0, or close to it. And then also, you really don't need these parts in your legend, so I like to delete these. I don't know, like I said, this graph may or may not have to go into your report. It depends on your TA, but I just delete those. So we've got these, got all our slopes of the velocities. So let's quickly do that for this graph down here as well, because we're going to need it anyway. So actually got to do the whole thing. So I'm just going to do that really quick. Actually, I'm just going to pause the video so I can get all this done a little bit faster. You've already seen it up here anyway. Okay, so I just paused the video to add in, I just added these labels: concentration of product, micromolar, the time in minutes, and then one thing that I also added up here, probably a good idea to make sure you label that this graph came from your row B data, so it's enzyme only, and then this graph was enzyme plus inhibitor. Just want to make sure that you remember the difference between those two, because what we're going to do is make the Michaelis-Menten plot for your row B data, and then we'll also do it for your row C data, although you may or may not have to include that in your lab report. It depends on your TA, what he or she wants. Oops. So I'm just getting those trend lines again, because again we want the slopes, that's what we're interested in. The next step that we're basically going to be doing is copying the values of those slopes, manually typing them in, so that we can make our Michaelis-Menten plots. This is why I delete these things, because they just get in the way and start taking up valuable real estate on my screen. Alright, so that is all done. We've got both of our graphs created, properly labeled, gathered the velocities, our substrate concentrations are labeled. So now we are ready to make our Michaelis-Menten plots. So going up here just to review, that's basically, we just did graph get slopes, now we're going to create Michaelis-Menten plot. And then after that we would create a double reciprocal plot. And we are actually almost done. But first off, how do we create the Michaelis-Menten plot? Remember, pretty much velocity versus substrate concentration. These are velocities, these are substrate concentrations. And again, it's very important to pair them up correctly. Now, I did this in reverse order. I know I did the 2.3 and then I went this way. So this 41 goes with my 2.3. And we're just going to type these values in. So let's think about, remember, Excel expects your X values on the left side when you type in values and the Y values on the right side. And this is going to be velocity versus substrate concentration. So substrate concentration will go on the left side since it's on the x-axis, and velocity over here because it's going to be on the y-axis. So let's just copy these. 2.3, 0.92, and now we need to pair up, type in the velocities, making sure we're pairing them up correctly. So this 41 goes first. And if you get one that's negative, that's okay, just copy it just as it is. And let's go ahead and do this down here as well. I'll go ahead and just copy this whole thing and I'll change the values. These are obviously going to be different. So again, starting with that 30 value and working my way down. And obviously your numbers are going to be different, but I'm just trying to show you how it's done. Alright, so now we're ready to actually make the graph, so we'll go ahead and select our data, insert, scatter plot, and this is what we get. It should be something of this general shape, you know, where it goes up. The example graph that Dr. Lefler has in his video is very nice. You know, your data may not look quite so pretty, but that's okay. Generally what I tell my students is, I don't care if you have good data, as long as you analyze your data, go through all the steps, you'll do fine. So I just clicked on the little layout button. We really don't need a series in this case. So what was on this axis? So we just did velocity. And what are the units of our velocity? Well, remember how we got velocity? It was these slopes. And remember, slope is rise over run, so therefore the units are rise over run, micromolar per minute. So that's what we'll type in over here. And I'm just going to use Greek symbols, micromolar per minute. Down here, what's this axis? Well, it was substrate concentration. And what are the units of substrate concentration? We talked about that just a little bit earlier. We were doing it in micromolar. So over here I'll write substrate concentration. And so up here we can label this as velocity versus substrate concentration. Now you don't need any trend line. This is not a linear relationship. The double reciprocal plot that we're going to make, the whole point of that is it creates a linear relationship so that you can analyze your data. Michaelis-Menten by itself is not linear, but the double reciprocal plot is. So there's no trend line here. And I'm not going to talk about it here because Dr. Lefler covers it in his video, but this is where you estimate your Km and Vmax values. You can go watch his video again to learn how to do that. But we are going to go ahead and make this graph, same thing down here for row C. You may or may not have to make the graph and include it in your report. It depends on your TA, but I will just show you how to do it again. All I did was the insert scatter plot. Go ahead and format this guy. Don't need that legend, and it's going to get the same treatment in terms of the labeling. Alright, so, and let's, there we go. Make sure that we remember that the other one was for enzyme, this is enzyme plus inhibitor. Okay, so this plot is definitely going to have to be in your report. Definitely going to have to be in your report. So make sure you got everything properly labeled and you understand how we made it and the purpose of this plot. Now, the last plot that we're going to make, actually the second to last plot, is the double reciprocal plot. It's basically taking these values and inverting all of them. So, what we can do, copy this, just moving our labels over. Instead of substrate and velocity, it'll be 1 over 1 over substrate and 1 over velocity. And to do this in terms of Excel, we can literally just equals 1 divided by, and go ahead and click over here and hit the Enter key. And then we can just copy this down and across. Now, we get this a lot, obviously, can't divide by 0, this last one's 0, so I just tell my students to throw away this last data point. It's just going to make your graph look funny. Now, this whole thing, if we copy it and paste it in just the right spot, I think that's right here. Yep. There we go. Got our values copied over. Easy peasy. Didn't even have to type it in again. Anyway, ready to make another graph. So we'll just select our data, insert scatter, and there we go. It should be linear. Mine's not so pretty, but it is what it is. Create a quick layout. Don't really need the series on here. And we can do the same thing down here. Insert, scatter plot, and I'll do a quick layout. And then this guy is pretty much, this is our double reciprocal plot. I think your biochemistry textbook calls it the Lineweaver-Burk Plot. You just give it a name that makes sense. And then you can label your axes the same as before, but obviously 1 over velocity and 1 over substrate concentration. And I'm going to do that really quick, but I'm going to pause the video to save some time. Okay, so all I did was just label my graph. So I labeled this one, this is 1 over velocity, and then the units, they would also invert. So minutes over micromolar is what I put. 1 over substrate concentration right here, so 1 over millimolar. And then I've labeled it, and then also just reminding myself this was for the enzyme. Down here, this was enzyme plus inhibitor. The other labels are the same. This graph, and again, I'm not going to go over how to do it. Dr. Lefler talks about it in his video, but this is the graph where you get your calculated Km and calculated Vmax values. You're going to want a trend line for this guy. So remember, you can just do add trend line. Maybe we'll do the r squared this time. Throw that in there. My r squared it's okay. It could be much better, but down here you're also going to want a trend line because again you're going to need that to calculate your Ki value. So there's our trend line there. Now one last thing I'm going to show you before we conclude this video, because your TA will likely ask for it, and frankly you need to do this in order to decide if your inhibitor is competitive or non-competitive, is to put both of these on the same graph. Now we've been doing this a lot, but I'm just going to show you how I would do it. So we can copy this, move it over here. Now since there are formulas hidden in here, I'm going to paste special and just paste the values. And then I'll just remind myself, these are the velocities for row B. I'm going to paste row C right next to it. Now they both share the same substrate concentration, so I don't need to paste this part again. I just need to pull the inverse velocity values. Copy. Go ahead and paste this up here, but I'm going to do paste special and only paste the values. So this is row B, this is row C. Let's make one more graph because your TA will likely want to see this in your report. Insert a scatter plot, and there we go. And then obviously we'll want to label this guy Series 1 and Series 2. So which one's Series 1 and Series 2? Well, if you click on if I click on just the red line, I can see Excel is telling me it's pulling that data from my row C. So Series 2, the red one, must be my row C data. So we can do select data and give it a label that makes sense to us. We can call this enzyme plus, oops, let's try that again. Enzyme plus inhibitor, because that's what we were doing in row C. Now let me go back. So there we go. Here we go, enzyme plus inhibitor, so series 1, the blue line, click on it, you can see it's pulling the data from the row B, so right click, select data, give it a name that makes sense to us, enzyme, click OK. So now we can tell the difference between them. All that's left is, label these. It'll get the same labels as what we gave it over here. This is still a double reciprocal plot with both of them plotted together. And the reason why we do this is that you can compare the slopes and the y-intercepts to decide if your inhibitor is competitive or non-competitive. That's something else that you need to declare in your report. And feel free to go rewatch Dr. Lefler's video on how to actually do that. Anyway, that is all. That is everything you need. As you can see, we clearly made a ton of graphs. You're not going to need all of these in your report. It depends on your TA, so please consult with your TA or try to remember what he or she said during lab to figure out exactly which graphs they want in the report, but otherwise that's it. Thank you for watching, and I hope you found this helpful.